Hello, Keith Rucker here at VintageMachinery.org. Guys, today working on a project for a customer, a viewer that had asked if I could help out with something. He's got a lathe. I want to say it's an Atlas. I may not be right about that, but he needs a new spindle for it. And he has sent me a couple of drawings for the new spindle that he needs made. And that's what we're going to be working on today, is making a new lathe spindle. It's a fairly small machine. I mean, 7.450 length, inch and 3/8 diameter on the widest place. But we got a bunch of steps to put in here. We got some threads to put in here. And probably the most challenging thing, at least I'm going to say that now because I've never done this before, I got to drill a hole all the way through this, a 1/2-inch hole. We'll have a Morse taper on one end of this, but I'm going to be using the gun drill to drill that out, and I've never used a gun drill before, so maybe it won't be the most difficult part, but it's the part that I'm most nervous about, I'll put it that way. So anyway, let's get in here and see if we can get this part knocked out. Start out here, just take a quick look at the drawing for it. Fairly straightforward, 3 steps on this side. Got a little collar here, threaded on the ends. Like I said, it's going to be drilled all the way through, and we'll put a #1 Morse taper on this end. And it does have a couple of Woodruff key holes that aren't on this drawing, but I got them marked on another one that need to go in there as well. So without further ado, let's get started, see if we can get this thing knocked out. There's my piece of stock, and I'm going to go ahead and chuck this up in the 3-jaw chuck. And step 1 is going to be to see if we can get that through hole through there. My idea is once I get that hole all the way through, probably do most of this job turning between centers, and we can kind of work off of that center hole that goes through there to make sure everything's running concentric. So anyway, there we go. We got it chucked up. I'm going to face this end. We'll put a center drill in there and start seeing if we can drill this thing out with the gun drill. All right, let's see if we can get this thing faced. All right. And now let's put a center in there, and we'll get started drilling that hole. Center drill here, we'll just spot that in to get us a good center hole to start on. There we go. Now they recommend with the gun drill to start with a hole that's already into the part to kind of guide it with. So we're just going to go ahead and use a regular 1/2-inch drill bit and drill on down in here pretty good little ways. And that'll give us a starting point. All right, I think we'll switch over to the gun drill now. All right, guys, we have now got our gun drill in here, and this is called a gun drill because it is for drilling a long, straight hole like you would in a gun barrel. And while it gets its name as a gun drill because that's what it was really originally designed for, they get used in a lot of other applications. Now, I'm not going to pretend to be much of an expert on these because, like I told you a while ago, this is the first time I've actually used one. But the way that this is designed, the front end of this thing is kind of an unusual shape, but it's designed to follow a bore and to stay in the center of the stock, finding its own center in there. Now, I will say that these things are really designed to go in special machines where they have flood coolant that actually goes up through. There's 2 little ports in the front. The coolant comes out and it actually pulls the chips out with the coolant. I don't have the means to put coolant through a tool on this machine, so we are going to be running it without coolant. I'm probably going to use a little bit of cutting oil on there just to be on the safe side, but I'm going to be extracting the tool frequently to clear those chips out, whereas under more normal situation, the coolant would just flush the chips out with it under fairly high pressure. So I'm just going to be doing things a little bit different here. All right, let's put a little oil up in there and see what happens. I'm just going to start by running it down till we get to the bottom. And it is cutting, it's drilling. And like I said, I'm gonna just pull that out periodically and clean those chips off. Get a brush. And we're just gonna peck our way down to the bottom of this hole. It's drilling fairly easily, which I'm going to take as a good sign. I'm just going about 2 cranks on the handle on the tailstock here and pulling it out so we can clear those chips. I don't want to load that up and risk binding the drill bit up inside that bore by loading it with too many chips. I will say this, it's actually cutting easier and faster than a regular drill bit. But with me having to withdraw it to clean these chips out, it might take a little bit longer, but I really like the way it's cutting. All right, here we go again. Should be getting close to coming through. There it goes. All right. Success. 1/2 inch hole through the part. All right, guys, I think we're ready to start turning this thing out. Notice I've got it between centers here. So I got a center on this end. This is just a piece of stock, and I true it up every time I use it to make sure it's running perfectly true with the machine. I got a live center in this one. I'm using a little bit different one that fits that 1/2 inch hole a little bit better than the little long snout one that I normally use. This is the side we've already faced. So first thing I'm going to do is kind of come in here and I'm just going to touch my cutter off on that end, and I'm going to zero my Z-axis on my digital readout. Reason is that the first step we got to turn in here is a 1 inch diameter, and it goes in 6.260 inches. And by zeroing that out, I can just dial right in there 6.2. Let's see, right there. So that's basically where I'm going to turn to, and I'm going to just zero that again. And that way when I'm turning down through here, when I get to 0, I stop. And now there's going to be a shoulder there. So kind of my drawing's upside down, but you get the idea. We're going to go to that shoulder. We're going to turn this 1 inch diameter. Once we turn that, we'll turn this 0.790, then this 0.750. So let's get in here and go to it. See, I think I'm going to start and go back to that 0. I just like to have a visual reference there. I do have a little bit of run out on the outside, but we're going to turn all that away. Let's Go ahead and cut it on down through there. Turning between centers like this will make sure that that part is running concentric on the outside with the inside bore. It also allows me to flip my part over, so when I get ready to machine that backside, I can just flip it around and everything will continue to run concentric with the bore. Anytime you're working off of an inside diameter like this, turning between centers makes a lot of sense. So anyway, that's what we're doing here. All right, let's get this turned down to 1 inch. All right, first pass. I'm gonna go get a micrometer and measure that. These measurements need to be dead nuts on, so I need to be real careful with them. These measurements all are very tight tolerances, so I'm going to be working from a micrometer rather than calipers on this. It's just more accurate. All right, that's 1 inch, 200. We're past 75 plus 6, so 281. 1 inch, 281 thousandths. I'm going to put that in my digital readout. We're going down to 1 inch. Take another pass out of there. Take another 100 thou out of there. All right, guys, I think what I'm going to do is I'm going to rough this out before we take it all the way. So I'm going to leave about 20 thousandths on the diameter, and we'll finish it all up in finish passes kind of after we get it roughed out. Main reason is we're removing a lot of metal right now, and it's going to cause this part to be a little bit warm, and I want to let it cool down and just do all those finish passes, real light cleanup passes after it has a chance to cool down. So right now we're just going to leave it a little bit oversized, get everything roughed out, and we'll come back and finish it up. So I've measured down to my next shoulder here, which is 4.525. Again, we're going to make a mark. And we'll come down, and this diameter needs to be 0.790. Again, we'll make it a little bit oversized, so we'll go to about 810. That should leave me about 20 thousandths to have to go in there and clean up. Again, make another mark. And this needs to be 3/4, so we're going to make about 760 on that diameter. Or 770. Let's go 770. Which is right there. All right. So what we're going to do now is let that cool down. We'll be back. I'll take a little lunch break, let that cool down. We're back at room temperature, and I think we are ready to finish this thing off. So we're going to come back down to this end and see what we need. That was 1 inch. And let's see where we are. We're cooled down here. We've got a little over 20 thousandths to take off. So we'll come in. We'll touch back off. Do this in 2 passes. That's about 10 thou there. And we're going to turn that out. For these finished passes, I did turn my feed rate down just a little bit, hoping to get a little bit better finish on that part. So we're at, what am I on? 3.3 thousandths per revolution feed. I was about twice that earlier when I was roughing it out. Got 6 thousandths to take out. All right, I'm gonna also need to clean up this shoulder. Let's see, that needs to be at 6.260. What we got here? We're about 1 thou over, and I'm probably just gonna use some emery and polish that out, because we need to get right on the money. Let me see if that knocked off any little rough places on that. See where we're at. All right. A few tenths over. I'll polish it on out some more. I'll just, I'm gonna go ahead, I'll polish that out once we get all the rest of these turned out, but within about 3 tenths of being where we need to be there. All right, next one here, 0.790. And we're about 810. So we got about 20 thousandths to take off there as well, which is just what we were leaving. So again, I'm gonna come in here and take about 10 thou. And then take the rest of it. See what we got here. All right, so we're right on 800 thou. I need 10 more to come out. All right, that's got that shoulder. Just fuzzing off any little high spots on there for when I mic it. It'll give me a better reading. And let's see what we got here. All right, just measuring pretty good across there. All right, that's good. Let's get our last one down here. This one goes to 750, 3/4 of an inch. I got all these measuring right on now. I had to do a little polishing in a couple of areas to get the tolerances just right, but looks good now. We need to thread this in down here. This is a 3/4 16 and needs to go in a 1/2 inch. I got a line there marking where the threads need to come out. Let's start by chamfering that edge. And then let's touch off right there. I'm going to dial in about 5 thou. Put some cutting oil on here. And we'll wait for a number to come around. Double check that pitch. And we are right on where we need to be. All right, let's thread it. Go back to my 0. More oil on there. I'm going to do a spring pass here. And let's do a test fit. And that fits just like a glove. We got it. All right, guys, we got to finish this up. Turn this end down here to 1 inch and thread it with a 1" 8 thread. We got a little collar here that's 315 thousandths thick. Now I have flipped my part around on here so that we can work on this end now. We're still turning between centers, so the part down here should be concentric. Everything should still be running true. Note that I use some little brass stock here to protect the finish on this piece here, so hopefully when we tighten that down we're not digging into it. You can see where we galled it with the screw there, but that's all going to be turned off. Now I've already kind of come in here with my calipers and just kind of lightly scratched a line right there where that shoulder needs to be, and like I said, we're going to turn that down to 1 inch. All right, guys, so I still got to thread this in down here to 8 threads per inch. But I don't have room in here, clearance for my cutter and everything like it is. Plus, I still need to ream this end of the piece for the inside Morse taper. And to do that, I'm going to have to put it in a chuck. So what I'm going to do is I'm going to go ahead and take it out of between centers here. We're going to put the 4-jaw chuck on here. I'm going to get this end dialed in just as perfect as I can. We'll thread it and then we'll put the Morse taper on the inside. And after that, I think we'll be done with our turning. I've got my part in the 4-jaw chuck. We've got it indicated in less than 1/1000ths run out on it, which is as good as I could get it. And we're ready now to put the threads on here. This is going to be, if we got this turned to 1 inch, it's going to be 8 threads per inch is what we need on the end. So I've got my machine set up here to do this. Got things slowed down considerably since we're going up to a shoulder. I'm going to start by just putting a nice lead-in chamfer on the front there. Go in here and touch off. We're ready to make our first pass here, and we'll check it with the thread pitch gauge. Eight threads per inch. A little lube going here. See what we got here. So, yep, that is going to fit just fine. I like it. Success. All right, let me figure out this Morse taper, and we'll get that done. All right, guys, I had to take a little break here and do a little figuring and get back up with the customer we're doing this for to get some clarification. He had said that he wanted a #1 Morse taper put into this. The problem is that the large diameter of a #1 Morse taper is larger than the hole we got. And I'm like, oh, that's not going to work. So I got back up with him, and he said, yeah, he had made a mistake, and what's supposed to be in there is a #2 Morse taper. So I got a #2 Morse taper reamer here that we're going to use to ream that out to final size. But before we do, I need to enlarge it and kind of get it close. So to do that, I'm just going to use a boring bar. I got a little small boring bar set up here. Now, this taper for a Morse taper is a little less than 1.5 degrees in one direction, so or about 3 degrees included angle. So I've got my compound set to just a little less than 1.5 degrees. We're just roughing in the taper right now. We will finish it with the reamer, and it'll be perfect, but I do need to go ahead and get some of that material out of there. The large end of this hole needs to be about 700 thousandths, and the hole that was drilled in there is about 500 thousandths. So we got 200 thousandths total we need to kind of take out in that taper, and then, like I said, we'll put the reamer in there and take it to final size. So let's go ahead and start working on that. This boring bar is thin, not very stout, so I'm just taking real light passes, taking my time here, and we're just going to kind of start putting that taper in there. Now it's going to cut at first, and eventually we're going to get to a point where it's kind of not cutting, and I can feel it in the cross slide here. We're not cutting there. So we'll come on back out. I'm gonna move it in a little bit, and we're just gonna whittle this out until we get it close to that 700 thousandths on the large end, and then we'll use the reamer to touch it up to that final size. We'll be back in a minute after I kind of get this opened up. See where we're at now. 240 or 6. You know what? I think I'm gonna go ahead and switch over to this reamer and finish it up with the reamer. Let's get set up for that. I got my number 2 Morse taper reamer in here, and I've got my lathe turned way down low. We're gonna lube this up really good, and we're gonna start coming in here and opening up that hole. Now we've already bored it close to the angle. This reamer will get it to that final angle, and you can tell we're going in this far, we're not even cutting yet. So, all right, we're starting to cut there. And I got a little black mark right there. That's more or less the depth we need to go. So we're just gonna very slowly and easily ream that out to the final size. And I'm gonna take some breaks here. We'll pull that out and clean that reamer out. We get a brush here. Just don't want to get it loaded up too much. But this reamer should put a nice, very nice finish in there on everything. And it will get everything to the exact taper angle that we're going for. All right, we're cutting again. All right, I'm gonna bring it out. That should be it right there. Yeah, we're right at 700 thou. So I think we're good. And I think we're done. Well, guys, I think we have got this part knocked out. It is all finished up. We've got all the lathe work done. All the dimensions on here measured right on the money. Everything specs out pretty much just like he had in his drawing. The only thing that is left to do is he had a couple of Woodruff keys that go in here. And I was going to do those, but he wasn't sure about the exact placement of them and exactly which key it needed to be. He said, just go ahead and send it back to him like this, and he would take care of putting the Woodruff keys in. So I'm not going to be doing that part of it, but everything else is ready to go. So anyway, nice fun little project, some precision work, everything checked out perfect on this thing as far as I'm concerned, and I think it's going to do a good job for him. So one lathe spindle to be sent out to my customer. Well, guys, with that is going to be a wrap. We'll get this thing packed up and headed back in the mail to him, and hopefully it will serve him well. I think it's going to do just fine. Very happy with how it turned out. Like I said, fun little project. Always fun doing some precision work where you got to really hit those numbers dead nuts on. We did that on this part, and should serve him well in his lathe spindle going forward. Guys, with that, we're going to call it a wrap. So as always, thank you so much for watching. Please do subscribe to the channel if you haven't already. Thumbs up, comments, always appreciated. It really helps with the YouTube algorithms and so forth, and helping to get my videos out there in front of other people. So we greatly appreciate you doing that. Big thank you to all my Patreon supporters and other people who support the site financially. We couldn't do all this stuff without your help, guys. You really, really make a big impact and really help keep things going around here, and I greatly appreciate that as well. And with that, guys, we're going to sign off. We'll catch you on the next video. Again, thanks for watching.